In our last video, we looked at how do we measure the strength of a linear correlation. If we happen to have noticed that there is a strong linear correlation and we have the equation of that line, we might say, we have the picture of that line, we might want to know what is the equation of that line, and we would want to know that so that maybe we could use that equation to try to make predictions about other values in other places. And so when we go through that, this process is called regression, and that line is a regression line. So the regression line, or line of best fit, or least squares line, this is the line that best fits the data. It is the line that if you look at all the points and found the distance from all of our data points to that line, it is the line that makes that all of the sums of those squared distances, it makes those distances the smallest. And it goes through that using using some calculus kinds of concepts. Anyway, that regression equation that we obtain, it is going to look like y hat is equal to b0 plus b1x. So that value b0, that is a constant. b1 is a constant that's going to be multiplied by the predictor variable x. And y hat, that is a predicted y value, a response y. So here, this value of y, this predicted value of y, it is not an actual value of y from this equation. It is a predicted value of y based on some particular value of x. So we'll see that in an example here in a minute. This regression equation that we get, it is worthwhile, it is good over the range of x values, or the domain of x values. So once we get outside of x values that are in our actual data set, then this regression equation, it's going to get worse in its predictive ability. We'll be less certain of its predictive ability as we get outside the domain of our x values. We go through, to find this regression equation, exactly the same process we went through to do the hypothesis test and get that correlation coefficient. So we choose analysis, correlation and regression. The independent predictor variable, that's the x value, we will choose that first, and the dependent response variable, the y value, we will choose that second. In our output for this go around, we are going to be interested in the regression coefficients. All right, so we have the same example that we looked at in our last video, but now we want to find a regression equation, and then we want to use that regression equation to estimate the winning bid if the opening bid is $1,000. So let's go over to StatDisk. We're going to try to find out what is B0 and B1 so that we get this equation, y hat is equal to B0 plus B1x. So we want to know what are the values of B0 and B1 that we will get. So we take our data, we're going to put it into StatDisk. So we have our data in StatDisk. Here in StatDisk, I'm going to choose analysis. I'm choosing correlation and regression. The x variable, so that is our predictor variable, that is in the first column, and the response variable, the dependent variable, the y value, that is in the second column. Right? So we would use the opening bid to try to predict the winning bid. So we evaluate that. And we have all of that information that we were interested in last time in the last video. But when we go down, we also see our regression results. And so y equals b0 plus b1x. So that y value, that represents your y-intercept, b0, that is shown right over here. So negative 34 point, if we go to one decimal place, negative 34.3. Right, so b0 is negative 34.3. And our value b1, it was right there, just below it, negative or positive 0.4. So 0.4 is our value for b1. And so our regression equation, the equation of the line, is negative 34.3 plus 0.4 times x. So that's the equation of that line. If we want to use that line to try to predict if the opening bid is $1,000, so the opening bid, those were our x values, the winning bid was our y values. If our x value is 1,000, we end up with y hat is negative 34.3 plus 0.4 times 1,000. And when we go through that, we get something like 300 and, I don't know, $65.70. So 365.7 is the predicted winning bid if the suggested opening bid is $1,000. Notice that 1,000, that does occur in the range of x values. Our x values go from 400 up to 1,500. So values in those range from 400 to 1,500, those we could predict with some degree of accuracy, assuming that this line is a good line. So that's our regression equation, our regression line, and this is the predicted value that when the opening bid is $1,000. All right, in our next video, we will take a look at multiple regression. So what if we want to use not just one predictor variable, but what if we have 2 or 3 or 4 different predictor variables? How do we go through that process? All right, we will talk to you guys again later.